How's it, guys? Craig here again from the Builder Beamer project. Nick should be along just now to start getting his hands dirty with me on trying to get the car ready for the 1st of February. But time to give you another insight into one of the upgrades that we did as part of our How Did We Actually Do That series. So let's have a look. So today we want to talk about the M50 manifold swap. So just to recap, we've got the M54B30 engine, 3-litre M54 motor, twin Vanos, and we're looking to swap out to the old E46 325 intake manifold. And I guess the question is why. We'll get to that in a moment, but before we do that, let's just take a look at the manifold which has come off the 3-litre engine and try and explain what some of the shortcomings of this manifold are. So the first thing to be aware of is this engine is obviously was the final evolution of the M5X range of engine derivatives, and effectively what that engine range saw throughout its life was an ongoing look to enhance fuel efficiency as well as drivability. So this engine firstly has got the DISA dual length intake manifold functionality. So there's a flap which sits inside here, and by twisting through 90 degrees it changes the path that the air has to flow through the intake manifold. And what that effectively does is it boosts torque at low RPM. Now that sounds like a great idea, not necessarily a requirement for the track, and one of the big issues with these DISA units is that they're hugely unreliable. So they take quite a hammering over time. There's a pin which sits in here locating this flap. The little pin wears in its hole, it falls out, goes into the engine, and generally causes catastrophic engine failure. As it happens, this engine has actually eaten a pin and survived it. It's the only one we've ever heard of that has survived it. And we took out a broken pin, but yeah, it did actually make it through that. So to get rid of this is actually, yes, it's going to compromise drivability fundamentally, but is actually improving on a point of failure. So we're quite happy to see this thing go in the bin. The second thing is that the unit is obviously plumbed full of nasty PCV hoses. It's got a very intricate crankcase ventilation system. The hoses do crack, then they dribble oil all over the place. It's just a dog's breakfast. So getting rid of a PCV system is also something which is nice to have. Then it's really not a requirement for the track. It's for emissions requirements. Obviously for road use you do want to try and retain your crankcase ventilation system, but in our case we're going to a catch can anyway, so getting rid of the PCV is actually a welcome benefit. So this is a big ass hunk of plastic, very complex, takes up a lot of space on the engine, makes it very difficult to get it on and off. You can't get it on and off quickly. But what are the main reason that we're really looking to make this change all lies in the size of the intake runners. And you can actually have a look here. They're relatively narrow runners, and they have a D-shaped profile. That is not by accident. This is apparently quite central to the flow of this manifold. But these ports are actually quite small. So the M50 ports are a lot bigger. They're oval ports, and we're going to have a look at the M50 manifold now. So here we have our M50 manifold. I'm going to swing it over into the plane that would be on the engine as we started. As you can just see, it's a far simpler piece of kit. There's one hole that's for the throttle intake or the throttle body, 6 nice big fat runners which run straight into the head. So this is a nice simple piece of plastic, and really does lend itself to a nice upgrade. In terms of ports on this thing, there's hardly anything. There's basically a port here. This goes to the PCV system from the M50. We'll see just now what we use that for. This is your air temperature or your temperature intake temperature sensing port, which is threaded. And then onto the business end of it, okay, we've got a vacuum takeoff, and I'll tell you now what we end up using that for. But these are our runners. So let's try and get a peek at this side by side, or our actual port sizes. So I don't know if you can really see quantitatively there, but perhaps with the aid of a vernier, let's have a little peek here. doesn't really matter what the dimension is, but I'm kind of, that's the width difference that we're talking about, guys. It's quite substantial. Height-wise, less so. I think there's a millimeter or a portion of a millimeter in it, but bigger all around. So, and these manifolds have been compared side to side by some guys overseas, and we literally see that this manifold flows something like 70% more air. It's huge. So yeah, with that in mind, then let's talk about what it takes to do the conversion from this M50B30 manifold to the M54B30 manifold to the M50B25 manifold. So I'm going to get rid of this thing, and we'll have a look at this. Okay, so the first thing is, you will have noticed, in fact you won't, I'll bring it back. The M54 has got the identical bolt pattern as the M50, with the exception of 2 extra studs. So the first thing that you are going to need to do is you're going to need to just remove from the head the additional studs, and that's very simple. Just put on 2 of the nuts, back them up on the side that doesn't have the little rotating washer on it, back them up, screw them out, and you get rid of these 2 guys here. So that's the first thing we need to do. The second thing is an optional step, and that is actually to port match. So apparently it's really doesn't make a massive difference. It makes, maybe the guys talk about the order of a horsepower, so a part of a kilowatt. If you want to do it, but effectively what it means is reshaping the intake ports on your head to match your intake. We have done that, and to be honest, it's actually quite a tough job, difficult to do neatly, difficult to do well, and really quite risky, because if you take off too much material, you will get to a situation where your port is not only mismatched, but that your seal may not sit on flat metal, and then you may have a vacuum leak. So possibly, something which one could avoid doing, and certainly doing it on the car is a bit of a pain in the ass. You've got to protect your ports, so you've got rags in there and whatnot. You're vacuuming and you're trying to clear stuff out. You're always going to get a little bit of aluminium that might make its way into the intake. It's really not ideal. So yeah, do that at your own decision. So the next thing that we need to do is we need to deal with your idle control valve. Now, some guys delete the idle control valve. It's going to make the car a bit of a pain in the bum. So there's no reason to. You can actually implement the idle control valve quite easily. So the first thing one does, this is the standard idle control valve bracket on here. There's just some extra bits and pieces. You can just grind them off, cut them off to leave it in a form that you require. And then this is the original idle control valve grommet. It actually has a kind of an elbow extension. I just hacked the elbow off. This actually fits perfectly in here where the PCV system used to fit, and then your idle control valve follows in after that. So that's how to get your idle control valve plumbed. We then need a little bit of pipe. And I'll tell you now where we're going to take the supply off for the idle control valve. In this case, because we deleted the HVAC system, we were left with some heater pipe, and so we've decided to use that. And in terms of connectors, these are nylon fittings. These are actually nylon irrigation fittings, 20mm fittings. I think this is 19mm pipe. It's a perfect fit. I will have to keep an eye on that. The nylon is apparently good for 150-degree operating temperature. I don't know how well it's going to respond to oil, and I certainly also don't know how the water pipes are going to stand up to the oil vapors. So we, and there's likely to be some in these pipes. So we'll keep an eye on how well these last. But you can go off and get hydraulic hose and do this anyway. I just happen to like using what we've just taken off the car. There are a couple of mounting points, so we'll make use of that to firm up bracketry, and I'll show you how that all comes together in a moment. Then we need to use the M54 air temperature sensor. The M50 version is a different type. The M54 version is a plug-in. It works. It basically used to have a little O-ring on this end here, and it had quite a bigger section. You need to simply grind this down. I'm hoping we can focus. You need to grind the diameter down, and then cut a thread on here. Put it through a die. You can do it quite easily. It's a little bit of manual work, and then that allows this to be screwed in, and it actually fits in. I mean, it's plastic on brass, so it's quite nice and snug. I don't think we'll have any leaks. Guys talk about putting a bit of silicone. I hate silicone, so if you want to seal it, put a bit of thread locking compound on it. It's not going to lock it, but thread locking compound is actually also a thread sealing compound, so it'll work perfectly for that. Next thing is onto the injectors. This is it's quite an interesting step here. The injector rail on the M54 has a completely different angle. It kind of sits in at an angle like this, and so what you've got to do is you've got to grind off the arms of the injector rail. So basically over here and there are arms which kind of stick up, and they bolt down onto the rail. They get in the way. If you keep them on, you cannot get this rail onto the M50 manifold. You have to cut those guys off, which leaves you without any mounting points. You then also have to turn your injectors through 180 degrees. They point backwards towards the intake side. In the case of the M54, here you've got to spin them around to make sure that they're clear, and then you can pop them in. Now, these are quite interesting injectors. They do not fire in a perfectly straight line out the end. They have an angled offset. So, and that is to make sure that in the case of the M54, they are basically squirting straight into the intake and are aligned. So this will be sub-ideal, but apparently no ill effects have been documented in terms of that, so they'll work fine. But if you do an injector upgrade at some point, then you'll obviously go for an injector which has a straight squirting pattern, and then that'll be fine. So that'll pop on then, and I'll show you again how we do a bit of bracketry. Then once we've got all of those bits and pieces, we get onto the bit which is probably the most difficult to deal with from a DIY perspective. And that is throttle body adaptation, because the throttle body of the M54, which you want to retain, it's the electric, drive-by-wire throttle body. We haven't changed ECU or anything like that, so we're retaining this. This is a different size. It's fractionally different in terms of diameter here. We're talking of the order of 1.5 mil or thereabouts, but it has a completely different bolt pattern, so we can't bolt this up. And in addition to that, this one has the seal on the throttle body, whereas and it comes onto a flat surface on the intake manifold. In this case, the seal is actually on the intake manifold itself. So as it happens, that makes our life a little easier, in that when you have an adapter plate made up, then effectively you seal from the throttle body onto adapter plate, throttle body onto adapter plate, and then adapter plate onto manifold. So you've got two seals in place. So I initially just made up like a wooden prototype, and I took it off to a mate of mine who's got a CNC shop, and then he laughed at me and took the measurements, and he took the parts from me, and he actually built proper adapter plate. So this is the toughest part, because this is something that most of us can't do in our garage. In principle, you could probably make this up quite easily from engineering plastic. If you could get your hands on a piece, you probably need about 15 mils of total thickness. You don't need this beautiful step and everything in there. You just need your 4 countersink holes, which bolt up onto the intake manifold, and then 4 threaded holes to mount your throttle body onto. So you could do that with a hole saw and a jigsaw if you had a nice piece of engineering plastic. It's probably the route I would go if I was forced to, but if you've got a mate, it's even better. So Simon, who wants to remain anonymous, thanks mate, this was bloody awesome. If incidentally, one-offs of these are quite expensive to make, but if there was a significant requirement for something like this, I could get him to do a run of 10 or something, and we could probably get them done at a reasonable cost. You can buy them from a web guy on the web calls himself Seems Legit Garage. They do a nice kit, and I think they charge $99, so what's that, $1,500? It'll probably cost you another $500 to ship it, so it's going to cost you $2,000 to get this here from the States, which I thought was a little pricey given the delay, the time that it takes to get, and the risks that you have. That's an option. We could probably do that at half the price if there were 10 people who wanted to go this route. Cool. So yeah, I'm gonna kind of bolt it up in a moment and then show you what it all looks like. But be careful, by the way. When I was on the hunt for this intake manifold, there were a couple of guys advertising online on OLX. The one guy, advertised an M50 B25. I confirmed with him that it was what he said it was, and then went out to go and see him in Alberton. And he just turned out to be a total bloody clown. He didn't know what he was selling, and he had two intake manifolds. One was a 328 manifold, so the B52 28, whatever that is, doesn't help skinny little runners. And then the other one was an M50 B30. That's the 2 liter. So here's how you check, because I was battling to actually get to a point where I could tell him to bugger off. But here it is. So underneath the intake manifold, you get the part number, but importantly, there's your 2.5. So you can eyeball it. This design with no ancillaries you can see that's what you're getting. That you're not getting the M54, and then just look for that 2.5 stamp there, and then you got the right thing. You typically pay about $1,500 for one of these from a scrapyard. If you can find them, and you'll probably get them under $1,000 if you can find somebody on on OLX or Gumtree or something like that who's selling it. So total cost of a conversion like this is actually not huge. Probably in for absolute top end $3,000 all in if you have to pay $1,000 for something like that. Good. All right, I'm going to put it all together and then we'll have a look what it looks like. Okay guys, so we've slapped it all together now. Nice new fresh gaskets in there. So the idle control valve is in place. It fits beautifully in its original bush, which has just been trimmed and jammed into the old PCV intake port. These brackets here, this is like a part of a little L bracket, a little shelving bracket. You can buy them from Builder's Warehouse for about 15 Rand. They're awesome because they've kind of got all these M6 holes and then a slot on either end. So you just buy a handful of these brackets, cut them to length, and you can pretty much bracket anything. And they they shape up pretty nicely. I had to put in a bit of a stagger there just to change the height. I found those to be awesome. There's our intake air temperature sensor, which has been cut to the right thread and then just turned in with a bit of blue Loctite, just to act as a thread sealer. This is the old kind of repurposed pipe from the HVAC, the heater coil or heater core side of things. So just repurpose some of that. 19mm internal diameter, brilliant on a 20mm irrigation adapter, nylon irrigation adapter, and then there's our beautiful flange. Really chuffed with this. This is awesome. So yeah, bolted up nicely to the intake with a couple of countersunk stainless steel cap screws or whatever you call them, and then onto our injector rail, again using the same kind of bits of bracket. I haven't done this side yet. I'll just make up another one today, and then pretty much hooked up and ready to go. So that's the guts of that. Next step now, let's install the throttle body and the intake boot. The intake boot, incidentally, is an M50 or E46 M3 intake boot, so you can use either of them. You'll see on Real OEM you get two versions, one with a single port, one with a dual port. I don't think we can get the single one in South Africa, but as it happens, we need the dual port one anyway. We're going to be using the one port for our catch can vacuum draw off, and the other port is for our idle control valve. So it works perfectly. This fits directly onto our 3-liter throttle body, so no problem there. The pain in the bum is adapting this to be able to fit onto our existing cone filter or whatever else you have as your airbox. So this doesn't work out really well, so you've got to end up cutting your secondary boot from the M54, and then I've basically just put a piece of PVC pipe in there. I just want to clean that up a little bit and maybe chamfer the edges. It's a bit Heath Robinson. I've hunted around. I couldn't find any nice silicone adapters or anything, or aluminium in the right size, so it'll be PVC for now. That might change in time, but let's get that hooked up. All right, so there we've got our throttle body all mounted up, and you'll see it is rotated. probably about 15 degrees, maybe 20 degrees. And that's obviously just to allow for the new threaded holes in the adaptive plate to miss the other holes, because they're just too close together. So you just need to rotate in the design of that plate. And there we go, beautiful. So yeah, ready to get bolted onto the head now. Let's just whip that over and how we've hooked up the idle control valve. So as I said, you repurposed pipe straight into one of those ports, and we're A for away. So I just need my hose clamp obviously on there. Then just one thing just to remember, and I'll probably show it to you in a different video, but the head has got 6 little holes about 9mm diameter right next to the intakes. These are not blind holes. They're actually connected to vacuum somehow, or connected to atmosphere, whatever. They've got to be plugged. So M10 little stainless steel grub screws. We'll just tap that quickly, get these guys in there, get them blanked off, and then we're ready to bolt this down. I have heard guys referring to, closing it up with JB Weld, which is the American version of Pratley's putty and stuff like that. Guys, just don't use that stuff on engines. I've come across I came across a motor that we were looking to buy to rebuild, and it had been worked on by a so-called professional. And this thing had so much Pratley steel and silicon and crap all over it, and it's just sloppy workmanship. There are very specific places where you're required to use silicon on a BMW motor at your kind of joint interfaces and so on. But for the rest of it, just don't use it. Use the right gaskets. Torque everything properly. If something strips out, helicoil it or time cert it, but stay away from gluing these things together with epoxies and all manner of stuff. You'll thank yourself for it later. Cool, man. I hope you've enjoyed that, and yeah, it's not a very detailed how-to. You see my camera work is very DIY. The purpose is really just to show you how we've tackled it. A lot of this information is on the web, but some of the detail was missing. So yeah, it's been a lot of fun, and we're really quite happy now with this baby that's ready to go on, and we're hoping to get another, let's say 5, maybe 10 kilowatts. Who knows? Who dares to dream? So we'll let you know once it's been on the dyno.